Algebra I, number 2.6f. We're still talking about division of rational numbers, and we're going to talk about terminating and repeating decimals in this video. So far we've learned that a rational number can be written as a ratio, a fraction, of two integers. And rational numbers can be written as a terminating decimal or a repeating decimal. A terminating decimal has an end to it. It terminates. It ends. You ever hear of a bus terminal? That's the end of the line for the buses, or for streetcars or train terminals. That's where the end of the line is. So terminate means to end, so a terminating decimal has an end to it. 0.25 is a terminating decimal. It ends at the hundredths place where the 5 is. A repeating decimal doesn't have an end to it. It has numbers that continue to repeat over and over and over again. 0.33 is 1/3 written as a decimal. It's a repeating decimal because the 3 keeps repeating. We write a bar over the repeating numerals to show this. That way when people see it, they know that we mean that the 3 is going to continue on and on. Well, there's also decimals that don't terminate or repeat. They continue on and on. And pi is one of these. They're called irrational numbers. See, rational means sane, makes sense, logical. Irrational, that IR in the front, means it's not rational. It's not logical. It's without reason. It's ridiculous. We round off numbers of pi, 3.14, or as a fraction it's 22/7, and we use an approximate sign because pi has no end. We can't do math with it, so we just use 3.14 and an approximate symbol because we're not exact. So here are the digits of pi. It's 3.14159.265. Oh my gosh, look at this. It hasn't repeated and it hasn't ended. It hasn't terminated. Look at this. It's still going, and more. Well, there are record-setting pi calculations to try to find all its digits. Alexander Yee and Shigeru Kondo surpassed 10 trillion digits in the year 2011. And it's still going. So, irrational numbers can't be written as fractions. Now, if you're still really confused, there's videos in the description of this video for links to similar videos that'll explain it to you, okay? So we can see why we just use 3.14 for pi, or 22/7, as a fraction. It's irrational. And the square root of 2 is also irrational. Square root of 2 as a decimal is 1.41421. Oh my gosh, it just goes on and on and on. So they're really irrational, okay? Pi and square root of 2. Well, we can write fractions in decimal notation. When the decimal repeats, we put a bar over only the part that repeats. Let's look at 3/11 as a fraction, and let's change it to a decimal. 3/11, well, it's a little division problem, isn't it? It means 3 divided by 11, so let's do that. 11 can go into 3. Well, it can't, so we need to add a decimal point here and in the quotient and add a bunch of zeros. When we do our long division, we see that it ends up equaling 0.27272727, and it'll keep going on. So the way we write it as a repeating decimal is 0.27 with the bar over both the 2 and the 7, because those are the numbers that are repeating. Let's take a look at 3/8. That means 3 divided by 8, doesn't it? So we take our 8 and we try to put it into the 3, and we have to add a decimal point here with some zeros and in the quotient. We do our long division, and we see that it's going to equal 0.375. And we get a 0 here. So there's no remainder. It's a terminating decimal. It does have an end to it. It stops at the thousandths place. See? Let's take a look at 23/9. 23/9 means 23 divided by 9. So 9 can go into 23 2 times. That's 18. We do our subtraction. We add a decimal point here and some zeros to finish it, because we're not getting any zeros yet. And we keep getting a remainder. So we put a decimal point up here in the quotient, and we find that the 5 is going to keep repeating in the quotient. We keep getting a 50, and then a 45, and a 50, and a 40, and it keeps going on and on. So it is a repeating decimal. And even though the 2 is a whole number and it's not repeating, this 5 is a decimal, and it is repeating. So we put a bar over just the 5. That's the only part that's repeating. See? Let's take a look at 5/18. 5/18 means 5 divided by 18. So What we do is we take 18 and try to put it into the 5, and we can't, so we have to add a decimal point and some zeros. And when we do our long division, we see we come up with a 0.27777, and that 7 is going to continue on. Now look at what happened. When we did 18 times 2 and got 36 and subtracted it, we got 14 and dropped down a 0, so that's 140. Well, 18 is almost 20. So how many 20s can fit into 140? 7. So that's why I used the 7 right away. I did a little math on the side to make sure I was right. Times 8 would have been too big at 144. And every time I did it by 7, I ended up getting the 140 and the 126, 140 and 126, and it kept repeating. So to write it as a repeating decimal, the 2 isn't repeating. There's only one of those. So I only put the bar over the 7. See, 0.27, and the bar is only over the 7. So those are terminating and repeating decimals, irrational numbers. And just remember that there's terminating decimals and there's non-terminating decimals. And the non-terminating ones are the ones that are repeating or irrational. Okay? Okay. Remember that there's links in this description to help you if you still need some more help. And I'll see you next video. Keep trying. Bye.